Alright, so let's take a minute here just to focus on the asymptotes of a hyperbola, which are lines. So if you recall, the equation of a line, standard form for an equation of a line is what we call slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. So if we have a hyperbola whose center is at the origin, let's take an example here. It centers at the origin, and the four horizontal and vertical points from there are 2 away and 3 away. The asymptotes, you go up 3 and over 2 to get another point, and the asymptotes always pass through the center, okay? Always pass through the center of the hyperbola. So, do the same thing, go in the other direction, and now we have our two asymptotes. And forget about where the hyperbola is, we're focused on the asymptotes here. If the hyperbola is centered at the origin, the y-intercept is 0. So that means we're actually going to deal with the equation just y equals the slope times x. So in this particular case, the equation of the yellow highlighted asymptote is y equals its slope times x. We have to find the slope. Well, luckily for us, we created it in order to get this point. Our rise over run was 1, 2, 3, so that's how much we rise, divided by the run, which is 1, 2. So our slope is 3/2. And so now we have the equation for the yellow asymptote. Let's do the same thing for the green asymptote here. It'll be y equals the slope times x as well, because the y-intercept is 0. Its slope, you rise 3, but you run -2, not +2. So in other words, the equation of this asymptote, the green asymptote, that negative can move to the front of the fraction, and we get y equals -3/2 x. So in general, we can describe both asymptotes with one equation by writing y equals plus or minus 3/2 x. This represents two equations, one with a plus, one with a minus, and it knocks out both asymptotes. Alright, let's look at the same exact situation, but if the center moves. You'll see how easy this is. So now I have the center and I have my 4 points. I can draw my asymptotes the same way, get the corners. Something like this. The difference here, I'm still going to use this equation, okay? Even though it doesn't go through the origin, my y-intercept is not the origin. It's much easier to deal with this, okay? So let's first understand where the center is. The center is at +2, -1. What that means is, in an equation, instead of x and y, I'm going to have shifted x and y's. So if the x is 2, if this number is 2 for the x value, then in the equation that means I'm going to have x minus 2. The reason for that is this 2 should make this 0 when I plug it in, and you can see if I plug in 2 for x, 2 minus 2 is 0. Okay? Similarly, if y is -1, I have to be able to plug that in for y to get 0. So what do you have to do with -1 to get 0? You have to add 1. So all the y's will be y plus 1's. So I'm going to start with y equals mx, except instead of y and x, I'm going to have the shifted y and x. So I'm going to start by rewriting those. Y plus 1 equals m times x minus 2, the shifted x. And you can put the y plus 1 in parentheses if you want to. It's not necessary in this case. And now all that's left is to find the slope of these. Well, you rise 1, 2, 3, and you run 2. So +3/2 is one slope. You rise 1, 2, 3, and you run -2. So you have a slope of positive or -3/2. And here are the two equations for the two asymptotes. And all we did was replace the y and x with shifted y and x to account for the new center.